All right, welcome back. This is for page 4 and 5 of section 3.4, properties of logarithms. In the first video, we went over the product, quotient, and power properties of logarithms. And in this video, our goal is to put them all together to solve a couple of these more complicated problems. So I'll start with page 4. We do kind of want to go over these basic properties of logarithms with you. First, log base b of 1. That's going to be 0. Why? I mean, they make so much more sense if you just rewrite this in exponential form. If you write this, the first property, in exponential form, you're writing something like this. The base is b raised to the 0 power equals 1. And isn't that so true? Anything to the 0 power is 1. So that's why the first property just makes perfect sense. Let's write the second one in exponential form. They said log base b of b is 1. What are they saying? They're saying b raised to the first power is b, right? And you know, when we just write this in a form where we've seen more before, that just makes perfect sense to us. Now the next one, let's rewrite this in exponential form. Log base b of b raised to the pth power is equal to p. Well, if you rewrite this in exponential form, we're writing the base is p, getting raised to the pth power, and that equals b to the pth power. And of course, left side equals the right side. So that is absolutely true. Now this one, you know what? This is an exponential and logarithmic form put together. I guess I want to just say like cancel and x equals x, but no, let's not do that. Let's go ahead and actually try to rewrite this in logarithmic form. So if I rewrite this in log form, what is the base? Base is b, right? And the argument is x. And that equals the exponent of this current form, log base b of x. And of course, we're looking at the left side. That is exactly the same as the right side. Just basic properties. And these are the 3 that we went over in the first video. Product property, quotient property, and our power property. Let's put all these together. Let's put all these together to solve or find the missing values here. Your Canvas quiz that goes with this part of the lesson is posted on Canvas. Just quick multiple choice problem, very similar to what we're about to go over, okay? Use the log properties to find the missing value. A, I have log base 3, but you know what I'm going to do is this. I'm going to just double check that I don't have any typo. The bases better all be the same if I want to use these properties, right? Log base 3, log base 3, log base 3. So they're all fine. The second thing that you should check is what's the operation in between. They're subtracting. So if they're subtracting, what rule are we using? We're going to be using the quotient property. Okay? So let's go ahead and combine these two into a single logarithm. Log base what? 3 of the quotient property says if you're subtracting these common base logs, we can divide these arguments. So therefore, this simplifies to log base 3 of 24 divided by 6 is 4. So if I fill in the missing blank, the answer will simply be 4. Okay, we're done with that one. Let's look at this one. Ooh, we got a blank on this side. We can temporarily call this x. I'm just going to call this x and I will find what x is. What I'm going to do first is to see if the bases are all the same. Log base 2. Log base 2 and log base 2. The bases are the same, and I noticed that we have a plus sign in between these two common base. So what property are we using? We're using the product property. Okay? So let's combine these two into a single logarithm. That will turn into log base 2 of x times 4 equals, now let me copy down the left side, okay? Copy down the left side. Left side said log base 2 of what number? 12. Okay, interesting. So what we are saying is, what do you have to multiply to 4? X times 4 equals 12. Can you see what x has to be? X has to be 3 because 3 times 4 is 12. So that one was kind of like a solving backward puzzle, but we were able to do this using the product property. I think the ones that I'm asking you to try on your Canvas quiz is a little more complicated, but I know you can handle this. You can do this. All right, let's do this one. Oh, notice that we have a number in front of it. That coefficient can go right as the exponent of that argument of 2. So I can write this as log base 7 of 2 to the what power? Third power. And if you simplify that, log base 7 of 2 to the third power is 8. Therefore, the missing value is 8 here. That was just the power property. We just used the power property. Nothing else. I want something more complicated. Let's see. Ooh, this one. All right, let's take a look. Guys, when I used to do this one way, but last semester, one of my students saw, hey, can we go ahead and just divide everything by 2 to start the problem? I said, you know what? That's a good idea. Because take a look. They all have 2, 2, and 2. So I was, when I was making up the problem, I was going to say, like, guys, let's bring up this 2 as the exponent. But, he was right. So this problem is not that bad. What I can change it to is I can first write this as log base 5 of, I'm just going to call this x for right now, plus log base 5 of 2 equals log base 5 of 6. I can just divide all these 3 terms by 2. Well, really factoring out the 2 from the left side and dividing both sides by 2 works just fine. Now let's take a look. First of all, do they all have the common base? The base is 5, base is 5, base is 5. Yes, and because they're connected by a plus sign, we get to use the product property. Oh, not property. Product property. So will it be wrong if we use the power property to bring up these x's to the numerator or to the exponent? Not really. That's okay. Our numbers are probably going to be a little bit bigger, but we're going to end up with the same answer. But let me go ahead and rewrite this as a single log, okay? That will turn into log base 5. Remember, when you're adding these two, log base, we're going to multiply x times. So we're going to multiply these arguments together. And they are saying that equals the right side of log base 5 of what number? 6. So they're both log base 5 on the left and the right side. So what must be equal to each other? X times 2 must be equal to 6. So what is your x value? X must be 3 because 3 times 2 is 6. Alrighty, so that's it for page 4. I'm going to ask you to try some fun problem just like this on your Canvas quiz. But, guys, don't try to do everything in your head. Try to write some things down as you are trying this. Because I know when it's like a multiple choice online quiz, some people think everything has to be done in their head. But definitely write things down and then try that Canvas quiz, okay? Oh, let's go over page 5. Now, I think these are something like what you're going to see on your Alex homework. So I just kind of copy a couple of these and put them over here. Same property, just a little different looking. All right, let's do A through F here, okay? Use the property to expand. So what they want you to do is if the first, these one, well, we didn't really have a direction. We're going to make them as long as possible, okay? So first one, I have log x cubed divided by y. I will use the, what property first? I will use the quotient property to separate them first, okay? Quotient property. I will say this is log of x cubed minus log y, okay? Not only that, I can go ahead and use the power property to bring down that 3 in front. And that's all I'm gonna do. The answer is 3 log x minus log y. And they just wanted you to expand it. So this is as long as it will just get. It's the equivalent, expression, but, just written in different form. And that's what they want you to do. That's what I want you to do when they're asked to, expand it. All right, let's do a couple more. Notice these are product of how many different things? I have 1. X is one of them. I got my y squared. I'm loving these colors on my pad. X times y squared times z to the 8th power. Write them out first as a sum of separate logs, okay? So I'm going to go ahead and separate these. Log x, right? Then what? Plus log y squared. Lastly, plus log z to the 8th power. Now, what property did we just use? We used the product property. Now, what do you notice? I noticed that a couple of these have an exponent. So I'm going to bring this 2 down, bring that 8 down. And the property that we're about to use is called a power property, right? So our final answer will be log x plus 2 log y plus 8 log z. And that's where we can stop for this, okay? Alrighty, let's go down to C. Oh, everything is under square root. So you know what? Before I separate any of it, I'm going to go ahead and just rewrite it first, okay? I'm going to rewrite this as ln natural log of xy to the 5th over z to the 7th. And what are they getting raised to? You know what? Let me bring this down. What are they getting raised to? How do you rewrite square root? How do you rewrite the square root? You can rewrite this as them getting raised to the 1/2 power. So that's the first thing I did. I rewrote the expression so they're not under square root anymore. They're getting raised to the 1/2 power. Now take a look and see what I'm doing, okay? Be very careful. Everything in this parentheses are getting raised to the 1/2 power, including x whose exponent is 1. It's just not written, but it's x to the 1st power, y to the 5th power, and z to the 7th power. So look, when you are taking power of power, you really multiply the exponent by the outside exponent. So this will turn into this. Watch very carefully. This will be natural log of x to the, now if you do 1 times 1/2, you will get 1/2. Y's original exponent is 5. If you do 5 times 1/2, you're going to get 5/2. Now z in the denominator, who used to have 7 as its exponent, will get multiplied by 1/2. So the denominator will, the z will have an exponent of 7 over 2. Kind of cool, right? So just have to multiply the outside power by each of their powers, and those are their new exponents. A lot of people forget about multiplying x to the 1st power, and that one, the 1 by 1/2, but don't forget that. Now we're ready to use the quotient property to separate them. Well, not only the quotient, now notice x and y are together, they're multiplying, right? So x, in between x and y, we're going to have a plus sign. So let's separate them. First, I will have ln natural log of x to the 1/2 power, and then I will have plus natural log of y to the 5 over 2. And then go ahead and draw minus natural log of z to the 7 over 2. We're almost done. We're going to now go ahead and bring down these newly written exponents as coefficients. And that will be it. Our final answer is 1/2 natural log of x plus 5 over 2 natural log of y minus 7 over 2 natural log of z. And if you're wondering why in the world do we need to do this? Guys, you're in a class called what? Pre-calculus. Everything that we do in this class, you're getting ready for a calculus class. And in calculus, it will be much, and you'll see why this will be so helpful. It will be easier to work with something. I mean, I know what we just got is much longer looking, but it will be easier to work with what we just got compared to what we were given in the beginning when you're doing one of these calculus things, okay? So, just gotta kind of practice, okay? All right, let's go over D. Ooh, another expression, but this time, if you take a look, this is a cube root that only extends to the numerator. Do you see what I mean? That z square in the denominator is not under this cube root. So I am not going to put, when I rewrite it, I'm going to make sure that z squared doesn't get raised to the 1/3 power. So let me go ahead and rewrite this first, okay? This equals log base 2 of x to the 7th y, and these two guys are getting raised to the 1/3 power. Are you okay with that? Because taking cube root of something is same thing as raising it to the 1/3 power, and we're gonna divide this by z to the 2nd power. But notice that z squared is not getting raised to the 1/3 power. Okay. Now y doesn't have an exponent. Write it down so that it's easier for us to see. Y is to the 1st power. Let's go ahead and multiply that 1/3 only to the numerator. So that will be x getting raised to the 7/3 times y getting raised to the 1/3. I gotta learn how to turn off these messaging on my iPad, because every time I get a phone, like a message on my cell phone, it shows it on my iPad. Anyway, sorry. The denominator will stay as z squared, okay? Denominator stays as z squared, but notice this didn't get multiplied by 1/3. Only these two got multiplied by 1/3 because those were the only ones who were under cube root. Now, let's separate these. I'm going to go ahead and write down this as log base 2 of x to the 7/3 plus log base 2 of y to the 1/3. And then guess what sign after that? Minus, because of z squared is in the denominator. So log base 2 of z squared. That will have a minus in front of it. Now, the fun part. Let's go ahead and write the exponents down as coefficient. And that will be the last step. So, what are we doing now? Bring down that 7/3 in front of this. Bring down that 1/3 in front of it. And bring that 2 in front of it. So, our final answer is 7/3 of log base 2 of x plus 1/3 log base 2 of y minus 2 times log base 2 of z. And that is our answer. That is how we expand a single logarithm into a separate 3 logs. Okay? All right. Hope you're doing good. Let's do 2 more and that will be it. All right, notice E, everybody's under square root. Everybody's under square root. So what I'm going to do is I'm going to just rewrite this so that this entire fraction, x plus 2 cubed over x cubed, they're getting raised to the 1/2 power. Okay, everybody's getting raised to the 1/2 power. Now, I'm going to now go ahead and multiply this outside exponent of 1/2 by the inside exponent of 3 and the 3 here, okay? This will be log of x plus 2 to the 3/2 power over x to the 3/2 power, right? Now let's separate this. But guys, you're not making x to the 3 power or 2 to... Notice how these two are... this is a binomial. That's a binomial getting cubed. So you got to treat it as, there's some getting raised to the 3, but then we're multiplying that 3 by 1/2. So we're not doing these two individually, okay? X plus 2 is a sum that we're taking 3/2 power to. So let's separate this. This is going to be log base, common log, x plus 2 to the 3/2. And what's the sign do we need to go to the bottom of this fraction? Minus log of x to the 3/2 power. Now we can bring down this exponents in front of it and say that our final answer is 3/2 log x plus 2 minus 3/2 log of x. And that's where we can stop for this problem. Lots of properties today, right? Now, finally, the very last one, f. And then I'll ask you to do more problems on your own, but I am done. Okay, now this one, now we just have to separate this, right? We just have to separate this. Okay, I don't really see anything to simplify first, so I will get right on it. I will separate these, starting with log 3. See where I got the 3 from? Log 3 right there. And then I see these two are multiplying. So I'm going to say plus log 2 plus x squared. But notice the other guy, the x cubed, is in the denominator. So I'm going to write minus log x to the third power. The only thing that I have left is probably just bringing down these exponents in front of it. Therefore, my final answer will be log of 3 plus 2 times log of 2 plus x minus 3 times log of x. Now, this one was way too simple to be our very last problem, but it was fun. It was fun to work with all these log properties. Hopefully, this lesson made sense, because now I'm going to ask you to try a couple problems on your own. And let me show you what they look like. You go to Canvas, and it's called 3.4 Log Properties Classwork. I'm going to preview the quiz and show you what it looks like, and maybe do the first one together. Use a log property to find the missing value. 3 times log base 7, 2 is equal to log base 7 of what? Remember, if you're doing this problem, it really helps to write things down. But notice that 3 can go up as the exponent. So 2 to the third power will be the answer. So 2 to the third power is 8. So your answer will be 8 for this problem. So I made this into like a numerical answer quiz. So your answers will, and you're not going to see the answer until you submit it. You have 3 attempts. This is due on April 19th. But take your time. These are very similar to what we went over in this video. You have about 10 problems. I think the last 3 are multiple choice questions. Just using all the properties. They look very, very confusing, but they're not. They just look a lot because they have all these log expressions. But please try. You really technically have 2 assignments for 3.4 lesson. I'm going to ask you to turn in this handwritten work, because I do miss seeing your work. And then I want you to take this short quiz on log properties, okay? All right, that's it for this lesson. I will see you later.